Okay, so this was the theory, and what we did then is to think about, can we really bring this to a product? And we have done this together with Amazon, actually Lab 126, where we had 4 servers spread out globally, TCP servers, where some Kindle readers based on Android can read data. And we made a small app which you just can say, where you can download coded TCP versus state-of-the-art TCP. We don't do it at the same time, we do it one after another. Just to not tell the people that our mechanism would be unfair. You have seen that we can make it fair, but maybe the people have the feeling, maybe it's unfair. So we do one test TCP, then we do one test coded TCP. And then we compare that. And while we do the test, of course it can happen that the parameters on the communication link, like error rate, latency, this, or even load, will change. It's not said that we have the same situation, right? But if we repeat it many times, then we can do something. And this was the first result of a cognitive density function over the seconds. There you see when coded TCP or normal TCP will have downloaded a file. We had a given file size, and then the coded TCP had an average delay of 2.72 seconds, and the TCP an average delay of 13. So this is factor 6, right? Factor 6 improvement over here. And when you look a little bit closer in the distribution, then you see here how often was coded TCP better than the TCP stream, and how often was TCP better than the coded, right? And you see if the uncoded TCP was better, it was only minimal. That means if the situation was more or less the same and the error rate was very low. You have seen in the curve that the coded TCP takes a little bit more time for processing. It can be that there are some milliseconds of processing, but then it's slightly better. So we gave this to the coded TCP. But what you see here, if TCP is faster, it is by a small amount, usually less than 1 second, right? In contrast, coded TCP download times are substantially lower. Here, over 30 seconds in 5% of the cases. And these were these cases that were dramatically bad for the user experience. If you wait over 30 seconds to download something on your Kindle, that is what they didn't want to have, okay? But this is now end-to-end. We are on the Kindle and we are on the cloud server. In between, we are not doing anything, okay? Now, another example. This is the Pacific Island testbed. It's an actual testbed in the Pacific, and you can see here a paper where they had now a satellite link over, here you see the satellite ground stations, and these are the islands around New Zealand, right? So they have internet and they want to bridge it over the satellite to the smaller islands. It's not that this is New Zealand. And what we did here is just to put an encoder decoder and here also an encoder decoder end to end. Everything here is transparent. Later you will see what you can do if you can break up this one. And this is what you see here, the Pacific Island testbed. Here's good put over 1 week. The black dots here are the errors, packet losses over time. And this is here in percentage, but you have to see it's a log scale. And sometimes if it becomes cloudy like here, the erasure rate goes up, or here, infinitive, right? Rain, this is rain. This is very good weather over here. Now, what you see is whenever the loss rate goes up, the TCP throughput goes down. And the coded TCP, yeah, also goes down sometimes, but sometimes it seems it's a little bit more stable, right? Here you could only guess what it is. If you take this plot, the same time series plot here, and you make a good put plot over the packet losses, so now you make it in dependency of the losses instead of the time, then you see it's very scattered here if you have TCP, but it's very stable if it's coded TCP. That you find some red dots in the middle is just an optimization problem, okay? And even here, the one feature of network coding, the sliding window, the low latency capability, made this one better than others. So in words of Morten, right? Morten is happy, network coding can shine here. Okay.